which helps us to monitor urban environments. Very important mission, or very important missions to be planned are hyperspectral missions. There are a few planned from Italy, the US, also Israel and Germany. This is an example of a German mission, a hyperspectral EnMAP mission. They will deliver about 200 spectral bands in a medium resolution, and these 200 bands will allow us to very precisely detect surface materials. So we will be able to give information about roof materials and materials of urban transportation structure, which will help us to monitor the cities. What else do we have? The Sentinel-1 system, it's a radar microwave system, was launched in recent years, and more satellites are to come. And it will also allow us to go into more detail with change monitoring of the urban systems, because radar allows different analysis of urban systems. Yesterday I gave a workshop. Some of you attended maybe the workshop, and I showed you what the Sentinel-1 systems are capable of. More detailed information can be gained by high-resolution, very high-resolution sensors. So the TerraSX sensor is one of those, which can deliver 1 meter ground resolution. In this case, it's again a radar satellite, so it can measure and give information on urban structures, very detailed structures. We can even do 3D tomography of cities with these systems. And also the height information is very important. So the Pleiad satellite system allows us to get with 50 centimeters with ground resolution, tri-stereoscopic images. So at one overpass of the satellite, we get images of 3 different directions. And with these 3 directions, it's possible to calculate the digital surface model with also 50 centimeters resolution. So it's possible really to calculate after this building volumes, to detect the number of floors of a single building, to calculate the biomass within a city. That's all factors which are recent developments of the last years. So this is an example of a digital surface model of our work in Da Nang City. So if you see here, maybe you know the city, that's the waterfront of the city central business district. Here's the landmark, the Big Novotel. Here's the stadium, and here we calculated this 3D structure of the city, which can be used to get information on building volumes, and also can be used later on for planning of, for example, possibilities for solar systems on rooftops and so on. So there are a lot of possibilities emerging. And one of the most important satellite systems, even though it's a commercial system, is the WorldView 3 and WorldView 4 satellite. It has a ground resolution of 0.3 meters, so it's very detailed, and that's also quite important. It has a high spectral resolution, so we get different spectral bands in the near infrared and also in the middle infrared, which allows us in a very high spectral resolution, ground resolution, get spectral information on surface materials. So here it's possible to get information on different materials on single rooftops, which will also be important for the planning of, for example, rooftop solar systems or wind energy systems. Here's an example of one of the WorldView 3 images of the Shanghai World Financial Center. You see it's very detailed. We can see the paintings on the road. We can see single persons walking on the paved road. We can see the cars and details of the cars. So there are a lot of possibilities emerging. So which topics are in the focus of recent research? That's quite important. What are people researching for? What are the topics they're targeting? To answer this question, me and my colleagues reviewed 8 international journals, scientific journals, and we reviewed them for the keynotes urban and remote sensing. And we had a look what are the topics of research. So the first point was how prominent is urban remote sensing, and so we did this research from the years 2008 to today, and we see that there's a growth of publications working with urban remote sensing. So a steady growth from 2008. 2016 is not finished yet. There will be some publications, so we expect also here that this will be a steady growth. So it's a very popular topic. And those are the most prominent topics targeted in these scientific works. So, well, they disappeared. Sorry for that. So, but I know that here we had socioeconomic analysis. We had urban structures, single building types. We had urban hazards, which were quite important. We had surface materials. There were water was a big issue. Urban hydrology. We had one big topic was urban planning. So all issues related to urban planning, they use different remote sensing systems. And we did some research about the scale. So what scale is targeted. So we see here that about 20% of the research is done on a global or regional scale, so on continental scale. Most work is done on a city-wide scale, so they're targeting the whole city. And some are even going deeper in the city, looking on city quarters, substructures, or even single objects in the city, so single building, single infrastructure. So that's about 10% already, but it will grow. Data that is used. Of course, there's LiDAR data, which is very important for cities. LiDAR data has a disadvantage. It's quite expensive, and if not many cities have this kind of data, and if they have it, it's mostly outdated. Therefore, LiDAR system might be a solution where we have per year several image acquisitions we can get for the city and calculate 3D data. Most work is done with optical remote sensing, coarse resolution, optical medium resolution, and high to very high resolution images. So that's a traditional analysis of urban systems. And also aerial images and images from drones, UAVs, is used in the recent years. And the methods used to target this different data are object-based image analysis, pixel-based, object-based of course, especially for the very high resolution data, but also different radar methods, 3D analysis of the LiDAR data and of high resolution stereoscopic optical data. And change detection was a big topic. So a lot of work is done on how cities evolve, where is the change of infrastructure, where are residential areas, what happens to residential areas, and where are land conflicts between rural agriculture and industry or residential areas. It's a really big topic. So we give 2 examples of recent research. The first example is on a global scale. It targets settlement areas, and the second topic goes into detail in a single city and targets single buildings already. So the global mapping of human settlements was always a big issue, and there was a lot of work has been done. This figure shows different methodologies and results of analysis with different kind of remote sensing sensors. But so with nighttime lights, we have MODIS data. The resolution is not very well in the most because it's a global product. But in the last year, the DLR, German Aerospace Center, finished one product. It's called the Global Urban Footprint, and they used very high resolution Teracer X and Tandem X data to or identify these human settlements. And they analyzed more than 180,000 images, so that's really big data. We're talking about more than 308 terabytes of data. It's really a lot. And the result is a 12-meter data set with a resolution of 12 meters, showing the global settlements in with a very high accuracy. So I give some examples. Here you can see the city of Istanbul. So the settlement structures are marked with the dark color. We have the city of Moscow, Sao Paulo. And please have a look on the different structures of the cities. It's very interesting. We have Ho Chi Minh City, New Delhi, Los Angeles, very densely populated, Tokyo. So there were some examples of a global product. That's one side of the analysis spectrum. And now we're going to more into detail. And here I can talk a little bit about my project. We're working with the city of Da Nang. My project is called Rapid Planning, and we're developing a transsectoral method for planning with water, sanitation, energy systems, food systems, and also waste disposal infrastructure. And therefore we need information. And this information is not always easy to get. We're not working just with the city of Da Nang. We're also working with other case cities in Germany, Frankfurt. We have in Rwanda, Kigali, and we have in Egypt, Asyut. And we want to develop a methodology. So in some cities we get some information, in some we do not. So we develop a holistic methodology. And the core of or the main idea of the analysis is that on one hand we collect information on land cover by very high resolution images. We process data for urban structure types and single building types. So we differentiate between different buildings. In the same time, some colleagues do questionnaires about socioeconomic issues, and also about consumption patterns within the city. So they ask how much water is used, how are the consumption patterns. We bring this data together and model the required capacity of supply and disposal infrastructure. And with the experts of the cities, we develop scenarios so that in the future we can give planning suggestions about different infrastructure. So what are the needs for infrastructure, not only today but also in the future. So this is an example of the city of Kigali, one of the case cities where we process urban structure types. So these are block-based information about the physical structure of a block. That means how are the single buildings situated within a block, what kind of buildings are there, what are the plot size, what is the building size, and so on. And with this information we calculate these structure types. At the same time we use the information, for example, the Pléiades satellite with the height information, with the information about the spectral information and some additional information to calculate mask of the building footprints. This is quite important information, especially in fast and very dynamically changing cities, that we know where are the buildings, what kind of buildings are those. So it's an example here. We get very detailed information. We have the 3D information of the buildings too, so we know in most cases about the number of floors, the building volume, which helps us to calculate for example, demand for energy. And then in the next step, we try to differentiate single building types, and that's quite research front. So we have some basic building types you see on the right side. Single family rudimentary buildings, villa type buildings, luxury buildings. We also have apartment buildings, we have industrial buildings, and we want to differentiate them in automatic. So far it's a semi-automatic way, but we want to focus on really developing an automatic methodology to detect these buildings and then to involve this information in our overall workflow. So thank you very much for your attention. I hope I could show a little bit about the potential of urban remote sensing, the need for data and urban, and that urban questions are quite important for all of us. Thank you very much.
Thank you so much. With limited time, I think that the person will be shared with you during the coffee break. Okay, yeah. Thank you so much. Tiếp theo xin mời ông Lê Phước Thành, công ty tổng giám đốc của công ty Vidagis, với cái bài trình bày là vai trò của SDI hạ tầng dữ liệu không gian trong quản lý điều hành đô thị. Xin mời ông Thành.